In the beginning of this project were many theoretical aerodynamic forms for a supersonic airliner. Hundreds were studied and rejected before the now familiar basic shape of Concorde was determined. Flight render delta aerodynamics and handling at subsonic, transonic and supersonic speeds. Past, another British research aircraft, the HP-115, has been demonstrating the superlative low-speed handling qualities of the slender delta. This aerodynamic research program, one of the biggest ever staged, used more than 50 different wind tunnels in Britain and France. Concorde's aerodynamic problems have to cover the widest. Concorde manufacture is broken down into sections suitable for road and sea transport. France, in yellow, does more of the airframe. Britain, red, more of the engine. Overall, there is a 50-50 balance. There are 2 assembly lines, but no duplication of sub-assembly work. Both lines will draw their components from the same sources. This line at Sud Aviation, Toulouse, where 001 and all the odd-numbered Concordes will be assembled. And this one at BAC Filton, where all the even numbers will be built. All nose fuselage made at BAC Weybridge. Assembling the fin of 001. Engine.
New Year's Day 1967, the last of the major British-built components for 001, the fin, leaving Bristol on its way to France.
Fuselage wing assembly, section 14. This too completed on schedule, being delivered to the assembly line at Saint-Martin. France is making the entire center fuselage and wing of the Concorde. A similar major assembly
arrival from France, another large center fuselage wing section for 002. It is sometimes suggested that there must be special difficulties in assembling an airframe from components made in separate factories hundreds of miles apart and in different countries. The second prototype begins to take shape. Perfect mating of the components is ensured by the use of established manufacturing techniques. If there is not much visible change, a vast amount of detail work has been done.
Research. Structural testing in miniature. This instrumented model is used to establish the characteristic vibration modes in the airframe structure.
Aircraft's stability and response characteristics. It permits simulated flights to be made in representative mechanical, climatic and visibility conditions. This then provides the data to function various flight deck systems, showing crew members the responses to their maneuvers. Huge new test facility for Concorde at RAE Farnborough. Before being transferred to Farnborough, the structural integrity of this large Concorde fuselage specimen was proved in the water tank at Filton. Particularly critical for the section of airframe concerned. Testing on this. Concorde testing involves major Anglo-French facilities. Vast quantities of compressed air on tap at the National Gas Turbine Establishment at Pystock.
15.
During these 6 months, testing and development of the Concorde's Olympus 593 turbojets has made rapid progress. A Vulcan bomber, adapted by Bristol Siddeley as a flying test bed for a production type 593, has been used to explore the engine's subsonic flight in.
Resplendent in its red, white and blue livery, the prototype was ready for its first move.
Although compared with the prototype, the fuselage is only 6.5 feet longer, by repositioning interior bulkheads, the cabin length has been stretched by more than 19 feet. With airline fuel reserves, this developed Concorde will carry 136 passengers non-stop over a 4,000-mile sector. It is due to go into airline service in 1971.
Anglo-French supersonic airliner, Concorde 001. The world's press was there to record this. 001's first... Finally, rounding off the week's trials, the aircraft streamed its braking parachute. All this provides a valuable introduction to a survey of ground maneuvers leading to the takeoff of Concorde